This is my 1941 Smith Mulvihill old-time rubber free flight airplane. I have recently installed a radio de-thermalizer system on this model, which I'm going to describe. The acronym for radio de-thermalizer is RDT. Basically, it allows you to push a button on that gray transmitter, which you keep in your pocket or on a wristband, and that tips the horizontal stabilizer to a 45-degree angle, causing the airplane to come down gently when you want to terminate the flight, particularly if it's flying to a dangerous area like a cornfield or trees, or if you're just doing trim flights and you want to terminate the flight early. It's a rather large model. It has a folding 16-inch prop. There's another video I've posted which shows how to put rubber bands on the prop to ensure that it folds. It has a spring mechanism in it so that when the tension of the rubber motor gets to a certain point, decreases to a certain level, an arm on the prop shaft hook engages a screw, and that stops the prop from spinning and the blades fold against the outside of the fuselage like that to improve the glide. I'm going to go ahead and activate the de-thermalizer system here using my handheld transmitter. It sends a signal to that little blue receiver with the antenna, which is powered by that silver lithium-ion battery. And when it receives the signal from my transmitter, it sends a signal to this miniature servo. The arm on that servo will rotate rearwardly momentarily, and through a linkage I'll describe later on, the stabilizer will tilt up. So I've got to stand back because if you're too close to the receiver, the transmitter overpowers the receiver. So I'll activate it at when I get to the count of 0. 3, 2, 1, 0. So let's start describing how this system works. You can see that the stabilizer has got a retaining shoulder here which engages the leading edge, and there's a rubber band which biases. It goes through a hole in the leading edge of the fin, and the ends of that rubber band are secured over basically a toothpick with rounded ends, which is mounted in the fuselage. I only have one rubber band on here. If I was flying, I'd put 2 because you want to have a very strong pop-up force. You don't want the stabilizer just kind of wimpy. You know, the wind, oncoming wind from the glide could make it not go to its full elevation, and you may not come down. So here on the trailing edge of the fin, you can see there's a little metal hook, and over that is a loop of monofilament line, which is held in position by a crimped piece of 1/16 aluminum tubing. This monofilament line is fed down to the subfin, where I have glued on a piece of electric wire insulation to route that monofilament DT line, let's call it. And up here you can see it goes through another guide, and on the forward end of this is a rubber band, which I will describe the function of later. An important part of this system is what I call a mousetrap assembly. Basically, you have a U-shaped piece of, I think it's 025 music wire, which is one leg of the U-shaped wire is journaled in a, or received in a segment of aluminum tubing, which is glued in with some balsa wood sheets and secured on a 1/64 sheet of birch plywood, 1/64 inches thick. It's a bit tricky for me to pull the DT line forward, but I'll put it on pause here and do that. I need two hands. Actually, before I do that, I need to set up the mousetrap here. So you can see that there's a little piece of what I call spider line, which is it's a fishing line that does not stretch. Here we have a coil spring made out of 9/1000 inch music wire, and it has a little loop on the end here. So we want to route this well, I'll have to, I'm going to take this loop here and put it over the arm of the servo, and I need two hands to do that, so let me pause again. So you can see the loop on the forward end of that coil spring is now slipped over the arm of the servo, which extends slightly in a forward direction, and compared to perpendicular direction from relative to the longitudinal axis of the fuselage. And over here you can see the other end of the spider line goes past the upward extending leg of the mousetrap. And the spider line, of course, is glued in one end to this little stub of toothpick, and the other end of the spider line is secured to the rearward end of the coil spring with, again, a loop and a cramped piece, or a crimped piece of 1/16 inch aluminum tubing. Now I'm going to stretch this DT line forward. Again, I'll put it on pause because I need two hands. Okay, so now you can see that the rubber band, I think it's a number 10 size rubber band, has been stretched quite a bit, and it is over this bent leg of the mousetrap arm, and you can see that slightly extends forward. I don't know if it'll focus because I want that to be retained. Now the important thing here is that I've decoupled the force required to hold the trailing edge of the stab down. I've decoupled that from the servo here. If I had that rubber band at a point stretched hard enough to hold that trailing edge of the stabilizer down, it would put undue stress on the very delicate gear train of this tiny servo. So instead, I have a tiny bit of stretch in that spring. Just, it's stretched about 1/4 inch from its relaxed state. That's just enough to hold it on that arm there. And then you can see that there's a lot of leverage here, so not much force is being put on the mini servo by that setup there. And so now, naturally, when the servo arm rotates rearwardly, then you're going to have that loop of the coil spring come off, and then the upward extending leg of the mousetrap is no longer held down. It pivots rearwardly under the spring force, and that little rubber band comes off, and the DT line goes rearwardly, and the stab goes up. So let's do this one more time, and I'll try to hold the transmitter behind me far enough away so maybe you can see this. I really can't. I should do this in slow motion, but I'm not good enough with my cell phone camera. So let's try it here. 3, 2, 1, 0. So there are other forms of de-thermalizers. The original form was a length of fuse, which was in the tail end of the fuselage, and it was in a snuffer tube, and it burned through a rubber band and allowed the stabilizer to tilt up. And then years later, a viscous rotary damper was used. inexpensive, but not as reliable, not very accurate, and you would set it to 2 minutes or whatever and hope for the best. The trouble with that system is that the viscosity of the fluid varies with temperature, so your time varies, and they do work. They're simple and they work. Another form of the de-thermalizer is the so-called band burner. It's a little circuit, and either with a timer in it or by remote DT transmission, there's a tiny little rubber band that goes across a nichrome wire, and when you send a signal or the timer reaches the target time, then that nichrome wire is momentarily heated for about 2 seconds. It burns through the rubber band, and the DT line is released. So I hope this is helpful to some of you. By the way, this model is pretty large. It's basically an oversized gollywog, and I'm going to put a GPS locator in it because even with the RDT may fail, or the thermal may be strong enough to carry it away. So the GPS should allow me to get a signal up to 3, 4, 5 miles away, and I can then locate precisely where the model has landed. I don't want to spend all kinds of time building something like this only to have it lost. Be a real pain. One other feature I will talk about, maybe I'll put another video about this. The fuselage comes down into 2 sections, it's reinforced with carbon fiber rods, etc. That's so I can disassemble the fuselage and put it in my standard size travel box, which I'll show you. Here is my standard size travel box. It's like 31 inches by 8 inches by 6 inches, and I can fit this entire airplane in there. The wing is disassemblable into 2 sections. You can see these music wire stubs that hold it together. Similarly, the fin can come out of that stab. It's just held in with 2 carbon fiber pegs which go into aluminum tube sockets in the stab. So if you're interested in a discussion of different DT systems, you can go to one of my videos on my 3-night P30 where I give a discussion of the other systems in more detail. It's a little bit repetitive with what's already here. So thanks for watching. I hope you find this video to be helpful.